that we'll be watching that I'm making for you guys this week. In this video, we're going to be discussing Chapter 19, Endothermic Vertebrates. These are all of the animals that we would consider, that we would normally think of when we think about animals. So the first ones we're going to talk about are birds. But what are some characteristics of endothermic vertebrates? So all known birds and mammals are endothermic, meaning that their heat energy produced during cellular respiration keeps their bodies the right temperature. What they're talking about here is the fact that the internal temperature is regulated. Endothermic means that the temperature is regulated by internal processes. That temperature is regulated by metabolism, and that metabolism is all of the chemical processes inside of the animal that help keep it alive. All of those things require energy, and a lot of the times that energy, when it's used, is transferred into heat. That heat energy produced by all of those cellular respirations, by all the metabolism, all that stuff, adds up to the normal body temperature of the organism. Now, because of that, since the endothermic organisms are constantly generating heat and doing all these things to maintain their life, they often need to eat a lot of food. And the main culprit of that is what they need to be able to sustain that body temperature, keep it up to where it's supposed to be, and using energy to do that. That requires a lot of energy, so they need to eat more often. Along with the fact that most endothermic vertebrates are going to have larger brains, they're going to have more complex forms of using those brains and a bunch of other things. So a lot of times the brain usage, metabolism, all that stuff is going to have a large impact, meaning that they have to eat a lot more. Okay. Another thing about birds is that birds are going to be the only animal that have feathers. So this is something that's only specific to birds. And as you can see there, okay, it's not talking about the ability to fly, because flight isn't unique to birds, but flight through the use of feathers is unique to birds. So that's why I mentioned this there. They have 2 legs, but they do have 4 limbs. So they still have the 4 limbs that have like arms and legs, except their arms are going to be turned into, for a large percentage of birds, those arms are going to turn into the wings that they use for flight, and then the legs are what they're going to use for standing on. Okay, these are a bunch of different types of birds. You got raptors, shorebirds, seabirds, wading birds, flightless birds, right? These are all different types of birds that you can see. If you want to know about these birds a little bit more in detail, okay, you can see all of these different types of birds on page 374 and page 375 of your textbook. I recommend you read through those 2 pages so you can see all of these interesting differences between all of these different types of birds. Now, when we talk about avian structure, okay, avian structure is really interesting because, first of all, right, their bones need to be strong enough to support that large energy and large force it needs to create flight, but also they need to be light enough to be able to allow these animals to fly. So because of this, their bones tend to be very hollow, and you can look on page number 376, and it shows you kind of what's the inside of these bones. And flight is something that's very difficult to accomplish, especially in animals that are as big as birds. So limiting as much weight as possible, right, that these animals have is super important, even down to the bone density, right, even to the point where a large percentage of birds, if they've eaten, they will actually use the bathroom before they fly to try to keep as little weight as possible, because the heavier the bird is, the more energy is required to allow for flight. So the bones are hollow, and even though they're hollow, they're very strong. Okay. Now, the way that a bird is capable to fly is through the use of those feathers. Those feathers, when the wings move, they cause thrust, and that thrust allows them to propel themselves up off the ground and through the air. And then as they glide, or as they hold their wings out, that again also allows them to to fly as well. Now, when we talk about feathers, the structure of feathers is also really interesting. And if you look on page 376 in your textbook, you can see the image of what these feathers look like and how they function. And the best way to explain it is if you've ever seen Velcro, right? Velcro is made of two parts. It has like that hairy part, and then it has the hook. Okay, so you have the hook and the hair, and the feathers that animals have work in a very similar way. They can actually hook on to each other, and this is what keeps these feathers from basically just breaking apart in a huge amount of wind resistance as they fly. And also, if you ever hold the feather, you can actually pull along the feather and you can separate the feathers, right? But then if you move your finger back in the other direction, you can actually make them reattach. So that's a really interesting way to keep those feathers together. Now, there are a couple types of feathers. You have the contour feathers. These are the feathers found that are the bigger ones, and these are the ones that are going to be mainly used in flight. Then you have the down feathers. These feathers are found underneath the contour feathers, and they're going to be more responsible in so in some animals that are going, or some birds that are going to be in water, they're going to help keep the animal, like the water away from the animal, but also they also help in regulate temperature. So they're kind of just smaller. There's smaller feathers that are going to help more in regulation of body temperature, since they're not really going to be in flight, whereas the contour feathers are going to be the bigger feathers that are going to assist in flight. Then you have those different types of wings, and those different types of wings are going to cause different types of flight. Okay, so you can see those wings on page 377. You can read those on your own. Some of these are pretty straightforward. High lift allows for flight, soaring, long periods. High lift wings allow them to quickly come up, and birds to basically come in, catch their prey, and pick that prey up. So that's why they're high lift wings. You're going to see these in bigger birds that are going to basically pick up their prey. Soaring wings allow them to fly for longer. High-speed wings fly quickly. And the elliptical wings are found in forest birds like owls that allow them to quickly maneuver through the forest. So those are a few differences there. All right, the respiratory system. Now, if we had a lot of time, I know that we don't have a bunch of time. This is something that we would be really interesting to go into a deep dive about exactly of how birds work, birds' respiratory system work. And it is super, super interesting and super cool to see how these birds are going to be able to breathe. And the reason for that is because flight requires a lot of energy. And as it requires a lot of energy, that means it requires a lot of oxygen. So how does the bird have a constant supply of oxygen while it's consuming so much oxygen during flight? We'll have to have a specially designed respiratory system, and this is what we see, okay? So it's very, very efficient, and basically what it does is it has several sacs that hold air. So instead of just having a couple lungs that hold air at one time, they actually have several sacs in the respiratory system that can breathe in and hold air and exhale at the same time. So you can breathe in air into those air sacs, and the other air sacs that already have the carbon dioxide, because this has been used, can allow for the exhale while the other air that's in another air sac is used. So it's really cool. And that allows for that constant influx of oxygen that the birds are going to need to be able to sustain, especially during flight. Now, you can see an image of this on page 377 on the bottom of the page. You can see all of the different types of air sacs that they can use to be able to hold carbon dioxide and oxygen and have that constant supply. Now, in birds, this is the first time that we see a four-chambered heart, other than in crocodiles. So crocodiles are the only other non-bird or mammal that has a four-chambered heart. Again, four-chambered heart is going to have larger size in comparison to the body. And for birds, these hearts tend to beat really fast because they need to supply that nutrients and the energy and the oxygen to the rest of the body really quickly. So the bird is going to need this four-chambered heart to be the most efficient type of heart, and making sure that all of the oxygen and all the carbon dioxide is being moved through the body really, really quickly. So the difference here is that you're going to have two atria and two ventricles. Okay, one atria, one ventricle are going to work with deoxygenated blood, and the other two are going to work with oxygenated blood. So one's going to receive the oxygenated blood from the rest of the body, pump it into the ventricle. That ventricle is going to pump it towards the lungs. It's going to go back to the atria or the other atria, and then it's going to go into the ventricle and pump that back out. So this is a really important. Another really important thing about a four-chambered heart is that it's going to be the first heart that there is, well, not necessarily the first heart, but in comparison to the third three-chambered heart, that there's going to be absolutely no mixing of blood. Now, there still may be a little bit of leftover blood in each atria and ventricle as it pumps. It's not going to have a perfect amount of release of blood from the ventricle or from the atria, but there's going to be no mixing of different types of blood. So no deoxygenated blood is going to mix with oxygenated blood in this heart. Okay, waste removal, they don't have a bladder. Birds have what we call a cloaca. So both the urinary system and the digestive tract are going to be expelled through the same process. It's going to be expelled through the cloaca. So that's why, if you've ever seen bird poop, it's kind of watery and all that nastiness, but that's why, because they don't have a separation between the two systems. They also have a beak, and in that beak they have no teeth. So most of the food, or basically all the food, has to be swallowed whole. Now, the fact that they have no teeth, I always like to mention that it's not that they don't have any form of grip or abrasion or stuff like that in the beak. Some of the beaks can have some roughness to them that can help them rip their prey or something like that. But what it means by teeth is that they're not going to be used for the chewing and tearing and breaking down of food within the mouth. So they're going to actually have to swallow that whole. The actual mechanical digestion, so the physical breakdown of food that we do in our mouth, the chewing, that breaks down our food into smaller particles. In birds, that's going to happen in the in the gizzard, in the gizzard. And the gizzard is going to be responsible for the mechanical digestion that we see. So since they don't have any specific teeth, they're not going to be capable of breaking down that food. So what do? They actually will be able to rip. So birds with that beak can grab onto food and rip it, and they can rip off basically small portions. You have scavenger birds that eat other animals, or even other birds that are going to eat seeds. But whatever they get, whatever piece they rip off, they're just going to swallow that whole, and that's going to be broken down in the gizzard. Okay. Right. Then you also have a crop. Okay, the crop is the storage of food. So this is kind of, if you've ever seen a bird with with a really big, full, in Spanish it's called un buche, okay, and it's like that's really full. It means it's eating a lot. So the bird can actually store some of that food in the crop, and from the crop it can be transferred to the gizzard, which allows it to break it down. All right, let's keep going. Birds have to eat a lot because they require a lot of energy, and since they have such a fast heart rate and all these different metabolic processes, they have a really high metabolic rate, so they need to eat a lot to be able to just basically stay alive. Birds typically have really large eyes that help them have really good eyesight. A lot of birds are going to be predator birds. That means that they're going to eat something, right? That doesn't mean they're predatory to everything. They're going to hunt and eat something. And if that's what they're doing, most predators rely on their eyesight to be able to see their prey, fly down, and eat them. Especially when you're flying at a really fast rate. So let's say you're flying at 25 miles per hour. Your eyesight is going to be really important for you. They also tend to have good hearing, and this is because they're not just predators, they're also prey, so they need to be able to hear if there's anything sneaking around them so they can go away. But a trade-off is that they can't smell. They have very little or poor smell. So some of them don't even have an olfactory gland altogether. Avian reproduction. So avian reproduction is really interesting. This is one of the habits that we see. We do see in reptiles as well, or other animals. But birds undergo this mating ritual called courtship, meaning that they have to basically win over a mate. And typically the male bird is going to be responsible for attracting a suitable mate. This is why, especially in birds, not all birds, but we see in a large majority of birds differences in appearance between male and female birds. And this is because the male bird is going to use those differences in appearances to be able to attract a suitable mate. This is why the peacock has those beautiful feathers, because they're going to use that to attract or scare away predators, but they're also going to use it to attract a mate. And also, a lot of birds are going to see, you're going to see them doing dances and calls and things like that. And a large portion of the time, it's doing that to be able to attract a mate. And some of the funniest things that you can see in a lot of documentaries are documentaries about birds and them dancing around and moving their heads up and down and shaking their tail feathers, trying to attract a mate or trying to win over a mate for courtship. Like it says there, some have new mates annually, so they'll mate for a year. Then the mom will stay with eggs, take care of the eggs, and eventually hatch. Sometimes both of them stay together and take care of the eggs, where the mom is the responsible, or the mother bird is responsible for laying on the eggs and taking care of it, where the male bird kind of flies around and takes care of it. A lot of times after the eggs are hatched, not all birds, both parents stick around. One will, either the male or female, typically the female, and the male will go on. Now, some birds, which is really beautiful, some mate for life. An example of this is the Canadian swan. Once the swan finds a suitable mate, they will never mate with another bird again, which is really cool. All right, so the fertilized eggs. So here's where we're going to talk a little bit more detail about how eggs work. We didn't talk about these very much when we talked about reptiles, but the bird egg is really interesting. So you have the embryo inside of the egg. The embryo inside of the egg is going to be the baby bird. And that baby bird is going to develop by attaching itself to the yolk. So the yolk is the food source of the baby bird. And as the baby bird consumes that yolk, right, it's going to be able to eventually have enough energy to break out of the shell. All right, like it says there, eggs must be incubated. That means that the mom has to sit on the eggs to keep those eggs warm, and as those eggs stay warm, they'll eventually, as the birds develop, they'll eventually develop the bird, and the bird will hatch out. All right, let's move on. So birds in the environment. First thing, migration. Migration is really interesting. So birds are not the only animals that migrate, but this is the first time we'll talk about. And we see this all the time, especially since we live in Miami. During the wintertime, we see all those birds fly down into here, and then we have hundreds of thousands of birds. Some birds that maybe you've never even seen before, they'll just be living here in Miami during the wintertime because it's so cold. So migratory birds are going to be birds that change location according to temperature. When it gets too cold, they'll fly south, and then they'll stay in the further south until it warms up, and then once it warms up, they'll fly back up north. Some birds will migrate not just in the change of weather. A large majority will fly in change of weather, but sometimes they'll also fly in response to reproduction. So according to their basically their life cycle, they'll fly into specific areas to allow them to reproduce. This is why you can see huge flocks of birds flying to one specific place. See this with flamingos, swans, and other things. Well, they'll fly to a specific place, mate there, have their babies, and then once their babies are old enough, they'll basically all fly back to wherever, and then that process continues, right? And it's really interesting. Sometimes some of these birds have never been there, and this is what we've talked about or you've known in the past, the word instinct. So these birds have something in their biology that just tells them where they need to go, even though they've never seen someone go there, and they just instinctively know how to get there, which is really interesting. Okay, now how do birds impact the ecosystem? So they are in a lot of different parts. So depending on what they focus on eating or what their diet is, depends on where they fall in the food chain. So some of them can fall higher up. We're going to be predatory, right? Some of them are going to be further down, and they're going to be more herbivore in style, even though most birds are going to be omnivore, but some of them are going to rely more on eating tree nuts and other things. Some birds, like the hummingbird, will eat nectar. So it just depends, right, where it falls on the food chain, and what it tends to eat is going to be what it is where it's going to fall in the food chain. So if it's higher up, it's going to be a great way of keeping things down. Like they're going to have a big, steady diet of insects, small rodents, small reptiles, stuff like that. So birds are going to have a really good part in keeping those nuisance populations low. So we can thank birds for that. But also, if they're lower down, they're a great source of energy for other animals, right? So that's really good too. Then some birds can be scavengers. Now these are opportunistic birds that they'll typically only eat dead animals, and these are really, really important birds. They're typically pretty ugly. We have quite a few of them down here in South Florida. They're called turkey buzzards, and they're part of the vulture family, if you know vulture from Tarzan or any other movie. And they're going to eat other dead animals. And the reason why they're so important is because they're a really big part of decomposition. So they'll eat a lot of things that other animals are not willing to eat, and that helps keep the food cycle continuous. So as they eat, they help break down some of that food, some of that animal or energy that other animals didn't want to eat, and then they can add that back into the soil, or eventually they get eaten. So that's also a really important part. So there you go. Those are birds. A lot of cool stuff about birds. Right, just a quick overview. Now we get to talk about mammals. Now mammals are really interesting because these are the animals that are most similar to humans, but humans, even though they are classified in mammals, we are not animals, right? God has specifically designed us, and we are set apart and different. So when God talks about mankind, especially in Genesis 1, God specifically mentions that humans are created in His image. And this is unique. There's no other aspect of God's creation, and God makes it. Does He say that He creates them in His image? So this is one major difference between humans and animals. And then secondly, when God makes man, He specifically mentions that He breathes into them the breath of life, and the reference of the fact that He gives them a soul or a spirit. Now this is the first time where God in His creation references the putting in of an eternal soul or eternal spirit into His creation. And humans are the only ones who receive that. So this is why we as Christians don't believe that we are animals, even though we have a lot of similarities, especially with mammals. We are still different and set apart because God desires to have a specific relationship with us. And in that specific relationship with us, when God came to the earth, right, we see, and there's a lot of stuff here, so stick around, follow along here. In Genesis 1, when Adam and Eve sin, right, God doesn't just hold Adam and Eve accountable. He holds the entirety of His creation accountable for Adam's and Eve's sin. Now, why does God do this? Well, this is just another example of the fact that God holds us to a higher standard than the rest of His creation. That the rest of His creation falls underneath man. Right? So this is another way. Another thing, also when God comes in the form of a man, in Jesus, and He comes to die on the cross, He comes to die on the cross for man, not for animals, not for His creation, but He comes specifically to redeem you. This is really important because a lot of the modern stuff out there, a lot of people are trying to make humans and animals the same thing, and that's just not the case, and especially not in the eyes of God. In the eyes of God, we are created different. Now, in mammals, what are some characteristics? So first of all, they have hair. Now, the amount of hair that a mammal will have can vary. They can be fully covered with hair and fur, or they can just have small amounts of hair localized in specific places, or they can have very little hair altogether. For example, a mole rat will have very little to no hair throughout the body, but it may still have some short strands here and there that are just not very visible. So most have two layers of fur that protect and insulate. They have an outer layer and a deeper layer. This is what they call the top coat and bottom coat. And the bottom coat is going to be more responsible for insulation and all those things and protection. And the outer one is going to be like the first step in protection. Now, there are a bunch of groups of mammals, the first of which are monotremes. These are the only type of mammals that are going to be capable of laying eggs. These are very interesting. An example of this is going to be the platypus. Another example is the echidna. These are the only mammals that are going to be able to lay eggs. All other mammals are going to give birth to live young. You can see all of the different types of mammals on page 382 and 383. Let's go through them here in a little bit. Then you got carnivores. Carnivores are mammals that are going to eat other animals. Pretty straightforward. A tiger is an example there. Lagomorphs, you can see these on page 382. Basically, types of rabbits. Shrew-like mammals. These are small mammals that tend to live in the soil. Bats, only type of mammal that's capable of actual flight. Rodents, rats. We should have done a dissection last week about that. Odd mammals, all these things you can see there. Examples of each one of these. You have odd mammal is talking about the armadillo. Odd-toed ungulates. Okay, when it talks about odd-toed, if you look at the hoof of a mammal, depending on how many hoofs it has on that foot, is if it's odd-toed or even-toed. Right, and you have some examples there on page number 383. Typically, the even-toed ungulates are the ones that we're going to be most familiar with. These are going to be like deer-like or gazelle-like types of animals. But if you want to read about them, they're on page 382 and page 383. Okay. There are a couple more. You have some other types of mammals, sea cows. These are I've not got on the name here. Let me look. Manatees. All right, these are manatees. Again, South Florida. Maybe a lot of you have come in contact with manatees. These are mammals that live in the water. Marsupials. These are really interesting. They have a pouch, and their babies are born really, really tiny. They'll move over to the pouch and then develop in the pouch. Simians and relatives. Those are going to look at things like monkeys and gorillas. Trunk mammals. Mammals with a trunk, like an elephant. And lastly, aquatic mammals. These are all the aquatic mammals that live in marine ecosystems, things like dolphins and whales. So, again, if you want to read some more, you can read that in your book. All right, mammalian structure. So, what makes a mammal a mammal? One, we already discussed, is they have some amount of hair on their body. Two, they are endothermic, meaning that they regulate their body temperature through internal processes. Very similar to what we discussed with the birds early on in this video. All of the metabolic processes added up to what the temperature is. Hair and blubber for insulation. That fat that's on right inside the skin of the animal is going to help insulate it from its environment to keep that heat in, and the hair and the fur is going to do the same job. Many pant to release heat, so animals that, for example, a dog that is covered in fur, they don't really have sweat glands. So if you ever walk your dog and you see it starts to pant a lot, humans will also pant a little bit when we go sprinting. Right, a lot of that is going to be, one, to make sure they're getting enough oxygen into their body to allow for that level of exertion. But secondly, it's also to cool off. So that's how a lot of animals will cool off, is by inhaling cool air and exhaling warmer air. And some animals, like the elephant, have those really big ears, and those are going to be used to release heat as well. Like it says there, heat produced by metabolism, eat frequently, but they have a relatively large brain. Mammals tend to be the smartest type of animals that are out there, or the highest IQ, or the ones that are most capable of using tools and things like that. So they have a relatively large brain, and with that relatively large brain, they put it to pretty good use. Most have good hearing and smell. Most have weaker eyesight than birds because they don't rely as much, because they're not, out there flying super far away and have to spot that one small insect and go and get it, or spot the fruit from really far away that they want to go eat. So they don't have to rely on as good as eyesight as birds do, but they have good eyesight, especially predatory or carnivore animals like lions and tigers. Their eyesight is going to be pretty good because they have to be able to pinpoint and catch the prey. So that's going to be really good. Eye placement, I've discussed this in the past, but eye placement is huge when we talk about mammals, because depending on where the eyes are located, it's going to basically signify to you what type of animal it is. So if you look at a mammal and his eyes are in the front of their face, like ours are, or lions, tigers, and dogs, That means that this dog is going, or sorry, that mammal is going to be more of a predatory animal, and it's going to be looking for prey, and they need those eyes to the front to help with the hand-paw coordination or hand-eye coordination. So they're more effective at catching something. Then animals that their eye placements are further to the side, we see these animals be more like they're more likely prey. And their eyes are further to the side so that they can see more of their surroundings. This is really important because they have to run away. So if they don't see that animal coming, they're probably going to get caught. So they have to be able to identify those animals, and the eye placement is a big deal. Like it says there, most have endoskeleton. It means they have their skeleton on the inside with 4 limbs, front legs, and hind legs. The digestive system is very similar to ours. They're going to have a mouth that allows them to chew, esophagus that allows the food to travel down into the stomach that starts the initial form of chemical breakdown, eventually into the small intestine, and when there, the small intestine, that's where the food is absorbed, and then the large intestine is where we'll see the cecum and all these other things. Kidneys are used to clean the blood, and they produce urine, and that urine is expelled as waste. So the kidneys are really important. These are like the janitors of our bloodstream, and they help keep your blood nice and clean and healthy, and any waste products that are in there is released through the urine. They have a 4-chambered heart, meaning they have a left, right atria, right ventricle, left atria, left ventricle, and their blood is going to be separate. An interesting thing about the blood system, the heart, like I said with the birds, is that it's actually going to have like 2 different pathways, right? You're going to have the part that receives the blood, and then you're going to have the side that pumps the blood out. So the atrias receive the blood, the ventricles pump the blood out, right? And I'm trying to see here so I don't get this wrong. I'm trying to go directly from memory, but I don't see it here. And we would discuss it more when we talk about the different organ systems. But basically, the right atria is going to receive blood from the rest, deoxygenated blood from the rest of the body. The right ventricle is going to pump blood to the lungs. That blood is going to go back to the left atria. The left atria is going to pump that into the left ventricle. And the left ventricle is going to pump oxygenated blood to the rest of the body, eventually returning back to the right atrium. And that's how the process works. They have large, flexible lungs, like, for example, our lungs basically take up our whole thorax, and they're going to fill up with water, with air by the use of the diaphragm. And the way that lungs work are super cool. So, something I love talking about is how actually the air gets into your lungs. So when we breathe, we think that the air enters into our body because we kind of like suck it into our lungs. But that's actually not the case. You can't actually suck air into your lungs. It's actually impossible. The only thing that you can do is force air out of your lungs. So how does air go into your lungs? I hear the sucking noise. I hear it coming in through my nose and then into my lungs. And it's actually going to function in a way of low pressure. So remember when we talked about diffusion and all these things, right? It's going to rely on all these processes to allow air to go in. But one of the major processes is that air hates low pressure. Air always moves into low pressure places. So if you guys know about vacuums, this is where there's no air, right? There's nothing there. And if there's nothing there, air hates that. So it has to rush in. If you remember when we were in the spaghetti supper and you had those spheres that we pull apart, right? If you remember, whenever I would open it, I would explain to you how the air would rush in, right? It's basically the same thing that's happening in your lungs. When your diaphragm pulls down on your lungs, it expands the volume of your lungs. And as it does that, it creates a mini little vacuum, right? And air hates that. So that noise, that sucking noise, is not actually you physically sucking the air into your lungs, but it's the increase of that volume, decreasing the pressure, and then the air can't help but rush in through your nose and into your lungs. So your body is actually going to rely on that process to basically forcibly move air into your lungs. Now, what happens when you want to get air out? Well, in your ribs, in between your ribs, you have these things called intercostal muscles. And those muscles can squeeze on your lungs. And as they squeeze on your lungs, they push the air out. So there you go. Okay, then a lot of them have a larynx. That is what they use to make sounds. Mammalian reproduction, another and the most important thing, the reason why mammals are called mammals is because they have mammary glands. And those mammary glands are used to produce milk. So every single one of the mammals, even the monotremes, and this is why monotremes are classified as mammals, is because they have mammary glands. If they produce milk, and so maybe there are some exceptions here and there, so they will produce milk, and that's what we classify them as mammals. Okay, they're going to be viviparous, and we talked about this in detail when we first talked about animals. You have three. You have oviparous, ovoviviparous, and viviparous. The difference between these and viviparous is that viviparous has a direct attachment between the mother and the baby developing inside. That's the major difference, right? So ovoviviparous and viviparous are both going to give birth to live young, but the difference is that there's a direct connection through the placenta and the umbilical cord from the mother to the child. And the mother is going to supply the baby with all of the nutrients it needs. And the exceptions to that is going to be monotremes, because those animals are actually going to lay eggs. All right, those will be viviparous. Sorry, not viviparous, I apologize. Oviparous. Now, they're going to reproduce through internal fertilization. That means that the sperm and the egg are going to meet inside of the mother. Okay. Eutherian mammals, embryos, let me move this over so we can see it a little bit better. Embryos attached to the wall of the mother's uterus by a placenta. This is what we talked about. And they have a long gestational period. So you guys know that the reason I'm not in school right now is because my wife, hopefully by now, has already given birth. And as you know, that took a long 9 months. Some animals can have a longer gestational period than that. Some animals can go even a few years, right? 2 years long. And some of them have a shorter gestational period. So it kind of just depends. But in comparison, or let's explain what gestation means. This means the time that it's inside of the mother. So the reason why it's so short is because egg-laying animals, that gestational period is going to be really short. It's not going to really live inside the mom for very long, right? Fertilization occurs, going to create the egg, and the egg's going to be, is going to basically come out. Now, in viviparous, it's going to be really long, upwards of a few years to a few months. Now, the interesting thing is that marsupials actually have a short gestational period. And this is what I referred to earlier, right, with regards that marsupials actually give birth to really tiny little babies. And when I give you that, I mean this tiny. They're really small. And those marsupials are actually going to have a pouch. So after the baby is born, okay, that the young little baby, for example, the kangaroo, is going to have to move from wherever the baby was born out of into the pouch. And then it's going to continue to develop inside of the pouch. And the mammary gland of the kangaroo is going to also be found in there as well. So that's where it can get the nutrients. But it's going to continue to develop inside of the pouch. And monotremes have a very short gestational period because they lay eggs. So they don't have to hold it for very long. Mammals in the environment. So they're found in almost every habitat. Like it says there, they form many different niches. They can be the apex predators like us, or like the killer whale, or they can be prey like deer or gazelle or other rodents and smaller mammals that are prey. Many have been domesticated, meaning that they've become pets like dogs and cats. And hunting seasons are used to help control population. Kind of flag through those a little bit because we're kind of running out of time here. And that's it. That's the last thing that we're going to discuss together. There's chapter 19 talking about the different types of endothermic animals. Hope you enjoyed this, and I wish you have a great rest of the day and the rest of the school year. I hope I get to see you guys again before the school year's over, but if not, I wish you guys the best. Have a great summer. Study for those finals. Work hard, and see you guys later. Bye.